The urn or container problem is a very common equally likely sample space probability problem. It will usually involve combinations, the multiplication principle of counting, and equally likely sample spaces. In particular, because of the equally likely sample spaces, the probability of any event, E, in sample space S, is just equal to the number of outcomes in E divided by the number of outcomes in S. Typically, what we're going to have is the following. We're going to have marbles, or we're going to call them balls, of several different types. In this particular case, we're going to have three different types: type A, type B, and type C. Small a identical balls of type A exist, small b identical balls of type B exist, and small c identical balls of type C exist in this urn or container. A plus B plus C, which we'll call N, is the total number of balls in the urn or container. What we now do is we randomly select a certain number of balls from the urn. Call it K. And if we don't say order matters, and we don't say we're replacing them, this is without replacement. So we're just selecting them out. Now, what random selection means is that any set of K balls has the same probability of being picked as any other set. This is what gives us our equally likely sample space. We can ask a bunch of questions from this. What's the probability that all the selected balls are A-type? What's the probability that X selected balls are A, Y of the selected balls are B, and Z of the selected balls are C, where X plus Y plus Z is K, the number of balls we picked out? What's the probability that no selected balls are A? All sorts of other questions related to this can easily be solved using counting. Let's look at a simple example. A container contains 8 red, 6 white, and 7 green balls. We're randomly selecting K equals 5 balls from the container. A few questions. What's the probability that all the selected balls are white? What's the probability that all the selected balls are the same color? What's the probability that no white balls are selected? What's the probability that 3 red, 1 white, and 1 green balls are selected? Now, how are we going to do this with R? Well, first we'll define N. And that's 8 plus 6 plus 7. Those are the total number of balls in the urn. That comes out to be 21. Now, we're selecting 5 of those 21 balls. So the total number of ways of picking 5 balls from the 21, number of combinations of 21 objects taken 5 at a time. That comes out to 20,349. First question is, what's the probability all of the selected balls are white? Well, if all of the selected balls are white, that means we've chosen 5 out of the 6 white balls and nothing else. So the probability of this is just the number of ways of selecting 5 out of the 6 balls divided by the total number of outcomes of the sample space, and you get a probability of 0.000294, etc. Next question. What's the probability that all the selected balls are the same color? Here's where we start using our theorems about probability. What does all the same color mean? It means all are red, or all are white, or all are green. These are mutually exclusive events, so to get the total probability of the ors, we add them. Now notice, this is the number of ways of picking the 5 out of the 8 red, number of ways of picking 5 out of the 6 white, number of ways of picking 5 out of the 7 green, and you get 0.004. Next question. What's the probability that no white balls are selected? Well, what does no white balls selected mean? It means that all of the selected balls are either red or green. There are 15 of them, so How many ways are there to pick 5 out of the 15 balls? It's just choose 15, 5. We're dividing by the same NS, and you get 14%. And the last question says, what's the probability of picking 3 red, 1 white, and 1 green ball? Well, we can actually select the 3 red in choose 8 3 different ways. That's 3 out of the 8 red. We could select 1 white in choose out of the 6 1 white ways. And we can select 1 green in choose out of the 7 1 green ways. But by the multiplication principle, since we have to choose 3 red and 1 white and 1 green, we can actually select those in I'll call it N311 for 311. Notice we're just multiplying the different possibilities. We get 2352. And our desired probability, which is the probability of getting that, is the number of ways, N311, divided by NS. And that's the probability of getting 3 red, 1 white, and 1 green ball when we select 5 balls from this urn randomly.